You have probably played or seen The Last of Us. It is a fungus that hijacks human brains, turns people into monsters, and ends civilization. These are terrifying concepts that make for great TV and even better video games. But here's the thing. They did not make it up. The fungus is real, the mind control is real, and the zombie behavior is real. The only difference, and I want you to hold on to this thought for the rest of the video, is that as of today, it cannot infect humans. I'm C, this is What the Flip Side, and today we're going down a rabbit hole that helped inspire one of my family's favorite video games and shows of all time. Now, I'm going to attempt the scientific name once, purely for credibility, and then we're never speaking of it again. Meet what scientists call Ophiocordyceps unilateralis. Something like that. Everyone else calls it the zombie ant fungus, and that is what I am going to call it. Because I am not a scientist. So let's take a non-scientist look at what this thing actually does. It lives primarily in tropical rainforests. Places like the Amazon, Southeast Asia, some parts of Africa, anywhere it is hot, humid, and dense. The kind of environment where life is so packed together that survival becomes a full contact sport. The zombie ant fungus has figured out something remarkable. Something that took millions of years to perfect. It doesn't just kill its host, it controls it. It spreads through spores. A single spore lands on an ant and produces a tiny tube that bores directly through the ant's outer shell and into the body beneath. Once inside the ant's bloodstream, it multiplies. It spreads. It grows through the entire body in a yeast-like form, growing throughout the ant while altering its behavior from the inside. And the ant has no idea. Completely oblivious. Just a normal workday, little did he know. For a while, the ant just keeps going, working, carrying food, doing ant things during a normal ant day, probably complaining about the commute. All the while, the fungus keeps growing. Now here's where it gets unsettling. The fungus alters the ant behavior, its instinct for climbing, gripping, and walking, controlling the ant to seek out the ideal conditions for the fungus's own reproduction. The ant starts acting strangely. It stumbles, it wanders away from the colony, which for an ant is basically death, since safety is in numbers. Then it starts climbing, up a stem, up a leaf, higher and higher. And then it stops. The ant clamps itself onto a leaf, roughly 25 centimeters above the forest floor, a remarkably consistent height that appears to maximize the fungus's chance of reproduction. The ant then bites down on a leaf vein. Hard. The ant will never let go. It goes fully lockjaw, and there, clamped to the underside of a leaf at the perfect height, it dies. But that is not the end. After the ant dies, a fungal stalk slowly bursts from its body, usually from the back of the head, and begins releasing spores that rain down on the forest floor below, ready to find the next host and continue the cycle. The ant's body becomes the fungus's base, its food source, its launch tower. Other ants passing below encounter the spores as they forage through the forest, beginning the cycle again. Now here's a question I found worth asking. If this fungus is so effective, why aren't all the ants dead? Why hasn't it wiped out every ant colony in the rainforest? Because ants, over millions of years, figured out a counter strategy. When an ant starts behaving strangely, stumbling, wandering, the other ants notice. They will physically carry the infected ant away from the colony and abandon it far from the nest. Some species even have dedicated workers who identify and remove the potentially infected colony members before they can spread the fungus. Basically, they invented quarantine tens of million years before humans ever thought of it, which is probably why they handle it better. Real scientists have found evidence in ancient fossils that suggest this fungus-host relationship may date back 100 million years. during the age of the dinosaurs, which I think could lead to a very entertaining Jurassic Park reboot. So, The Last of Us. We now know that the zombie ant fungus is found mostly in tropical forests and infects ants and other insects. Once it infects an ant, it starts growing and manipulating behavior, controlling the ant to leave the nest and clamp to a leaf at the perfect height for maximizing spore dispersal. The creators of The Last of Us took that premise, fungus that hijacks behavior, spreads through a population, and turned hosts into unwilling vehicles for its own reproduction, and asked one question. What if it jumped to humans? The main distinction between the fictional fungus and the real one is that the zombie ant fungus is currently unable to infect humans. Currently. It's totally fine, time to move on. One reason it can't, right now, is temperature. The human body runs hot. Our internal temperature is hostile to the fungus. It evolved for insects in tropical forest environments and not warm-blooded mammals. But scientists do note something worth keeping in the back of your mind. Climate change is warming the planet. Fungi, all fungi, are slowly, gradually adapting to higher temperatures. Some researchers have flagged this as a genuine long-term concern, not for zombie ant fungus alone, but for the broader category of fungi that might, over generations, bridge that temperature gap. Not a reason to panic, just a reason to find the fiction slightly less fictional than it used to be. So next time someone tells you to get off your phone, go outside, touch grass, experience nature, you can tell them you thought about it. You really actually considered it. And then you remembered that the grass has spores, the forest floor is basically a zombie factory that's been running since the dinosaurs, and your phone has never once tried to control your... Yeah, never mind. Get outside, touch grass, risk a real-life Last of Us situation. We have many more stories like this coming up, mostly just things that we find interesting and decide to take a deeper look at, so we can all understand it a little better and have some fun along the way. If you haven't already, drop us a like and subscribe because we're just getting started. I'll see you in the next one.